Hello dear student, how are you? I hope you are all will be fine. I am also fine, thank you. Welcome to your channel. Let's start today topic. Today is lecture number 6 of Boron family. In previous lecture I already explained you the similarity between boron and aluminum, but in today's lecture we will be explain the dissimilarity or differences between boron and aluminum. Dissimilarities between boron and aluminum Yeah, so let's start the topic. What is the differences between boron and aluminum? Let's start the topic. Yeah, here this is boron, here is boron, and this is aluminum. This is aluminum. Boron and aluminum. So number first, there are 2 electrons in the penultimate shell of boron, while 8 electrons present in the penultimate shell of aluminum. This is the boron. Number first, 2 electrons present, sir. 2 electrons present in the penultimate shell. 2 electrons are in the penultimate shell. This is 2 and 3. This is the electronic configuration. Here 2 is the penultimate shell, this is first shell. In boron has 5 electronic configuration, whereas 1s2, 2s2, 2p1. This is the electronic configuration of boron. This is the valence shell, and the below shell of the valence shell is called penultimate shell. This one shell means n-1, where n is the valence shell. So n-1 shell is called penultimate shell. So here in penultimate shell there is 2 electrons in case of boron, while in case of aluminum, this is aluminum. In case of aluminum, there are 8 electrons in the penultimate shell. There are 8 electrons in the penultimate shell. That is, the electronic configuration is 2, 3, 8 and 3. This is the electronic configuration. 3 is valence electron. In case of aluminum, the electronic configuration of aluminum is 13. So it becomes 1s2, 2s2, 2p6, 3s2, 3p1. This is the electronic configuration. Here is 3 is the n. So the n-1, the penultimate shell will be n-1. This will become n. That is the 2. Means the 3 minus 1 is 2. This is the penultimate shell. Below the shell of the valence shell is called penultimate shell. So here in the valence shell there is 3 electron, while in the penultimate shell there is second shell. Here is 2 plus 6. This is 8 electron. So in case of aluminum, in penultimate shell 8 electron present, while in case of boron here is 2 electron present in the penultimate shell of the boron. The second thing is difference is boron is non-metal. Boron show non-metallic behavior. While aluminum show metallic behavior. It is metallic behavior. It show metallic behavior. This is another difference. Why boron doesn't show metallic behavior? Because it has very small size. Due to its small size, it has high emission energy. So that's why they show non-metallic character. The another point is the another difference between boron and aluminum is it is bit conductor of heat. It is bit conductor of heat and electricity. Conductor of heat and electricity. But in case of aluminium, it is good conductor of heat and electricity. Good conductor of heat and electricity. The another difference between boron and aluminum, here boron is, it has very high melting point, melting point up to 2300 degrees centigrade, while the melting point of aluminum is not enough high. The melting point of aluminum is 660 degrees centigrade. This is the melting point of aluminum. Why boron have high melting point? Boron have high melting point because boron, it always show in giant polymer form, either in liquid state or in solid state. So that's why they have very high melting point as compared to aluminum. The another difference is boron show allotropy. It show allotropy, while aluminum doesn't show allotropy. It show crystalline as well as in crystalline boron also can be exist, while amorphous can also be exist. So here in case of boron, crystalline as well as in amorphous, both forms are exist. That's why it show allotropy. While in case of aluminum, it doesn't show allotropy. Aluminum doesn't show allotropy. The crystalline form of boron is very hard. Crystalline form of boron is very hard. Form of boron is very hard, while aluminum is not hard. Aluminum is soft. Aluminum is very soft. Not very soft, but sufficiently soft. Aluminum is sufficiently soft. Sufficiently soft metal. Here boron form covalent compounds. It form covalent compounds. Boron form covalent compounds, while aluminum form covalent as well as electrocovalent compound. Aluminum form covalent as well as electrocompound. Covalent and electrocovalent compound. The boron form electrocovalent compound, aluminum form covalent and electrocovalent compound, while boron form covalent compound only. This is the another difference. And the reaction with hydrogen to form number of hydrides. Boron form number of hydrides. It forms number of hydrides. While in case of boron form number of hydrides when it react with hydrogen. That they form B2H6, B5H9, etc. While in case of aluminum, they doesn't form any hydride. Doesn't form any stable hydride. It forms hydride, but it doesn't form any stable hydride. Can I ask that why aluminum doesn't form stable hydride while the boron forms stable hydride? Can I ask the question? Am I right? The question is right. Now I am answering the question. If you have answer of this question, then please comment me in comment section. Let's please pause the video. Okay, aluminum doesn't form any stable hydride because in case of aluminum, the orbital that are shared with hydrogen, in case of aluminum, that has the outermost shell orbital is 3p orbital or 3s orbital, while in case of the boron have the outermost orbital is the share orbital is 2s or 2p. So with the orbital of with overlapping of orbital of with hydrogen of 1s, orbital of 1s of hydrogen, 1s of hydrogen, when they overlap with, in case of hydrogen, the energy difference, the symmetry or the shape of the orbital of the 2p and 2s as compared to 1s is not enough high difference, but in case of 3p and 1s it is very large difference. So that's why aluminum doesn't overlap effectively, this orbital doesn't overlap, 3p doesn't overlap effectively with 1s, while in case of 2p as compared to aluminum, comparatively aluminum, boron has effectively overlapped with hydrogen. So that's why boron forms stable hydride while aluminum doesn't form unstable hydride. I think points will be cleared. And so on. After the aluminum, that is gallium, which has in the valence shell is 4s electron and 4p electron. So that's why 4s2 4p1. So these are the very large difference in the hydride of gallium, the in between the overlapping of 1s of hydrogen and 4p of gallium. So that is why these are very large difference. So that's why their hydride will be very unstable as compared to aluminum or boron. So from the result, from it can be concluded that the down the group the hydrides formation are decreases. Means it means that in the same group thallium doesn't form any hydride. Due to thallium has 6s and 6p orbital, which have very high difference in the size as well as in the shape, in the symmetry of the 6p orbital and 1s of hydrogen orbital. So that's why they cannot be overlapped, and so that's why thallium doesn't form any hydrides. I hope my point will be cleared. So now I am cleaning the board to proceed the topics because of lack of space. If you have any confusion, you can ask me in comment section, as well as you can rewind the video to make clearance in the topics. Okay, thank you. You can take screenshot. Okay, thank you. The another difference is the next difference is in between boron and aluminum is that boron doesn't decompose with water or steam. Boron doesn't decompose by water or steam. While in aluminum it can be decomposed by steam to form hydrogen. While aluminum it can decompose water to form steam. It can decompose steam to hydrogen to form hydrogen. Like this. That is aluminum in case of 2A when add with 6 water. When 6 water, it decomposes into aluminum hydroxide, Al, it forms aluminum hydroxide plus 3H2O will be evolved to the atmosphere, hydrogen gas. So aluminum can decompose steam, that is hot water, very hot water steam. So it can be decomposed steam, while boron doesn't decompose in steam or water. Similarly, in case of boron doesn't react with dilute acids. It doesn't react with dilute acids. Does not react with dilute acid. Dilute acid means that may be HCl, H2SO4. That are dilute acids. Here is two words used. Not here, but the word from this I will remind. Dilute and concentrated. One is concentrated acid or one, you can say that concentrated solution, one is dilute solution or dilute acid. So what is meant by dilute? Dilute mean where the concentration of solute is very less. Concentration of solute is very less. While in case of concentrated solution, the concentration of solute will be very greater. Means the solution will be very high, very denser, will be very high. Solution will be very denser, while the dilute solution will be rare solution. I hope my points will be clear. So boron doesn't react with dilute acids, while aluminum can react. It can react with dilute acids. Can react with dilute acids. It can react with dilute acids. Like in, for example, 2Al, when they react with aqueous force, that is sulfuric acid, it produce Al2SO4 3 plus hydrogen gas will be evolved to the atmosphere, hydrogen gas. So boron doesn't react with dilute acid while aluminum react. Here, in case of boron, boron can be oxidized by it is oxidized by concentrated HNO3. It is oxidized by concentrated HNO3. Now the difference between dilute and concentrated will be cleared. Concentrated HNO3, that is nitric acid, to form boric acid, it produces boric acid to form boric acid. Like in case of when boron react with 3 molecule of HNO3, it produces into boric acid, that is the formula of boric acid, H3BO3, that is the formula of boric acid, plus 2NO2, that is nitrogen dioxide. But in case of aluminum, it decomposes passive with concentrated nitric acid. It decomposes, it oxidizes passively. Passively means not enough, like in case of oxidized, the rate will be very slow. Passively with concentrated HNO3. So this is the one difference also between boron and aluminum. I hope it will be cleared. Here in case of boron can be dissolved in fused alkali to form hydrogen. Here boron can be dissolved in fused alkali to form hydrogen. For example, that is 2 atoms of boron, when they react with sodium hydroxide, it decomposes and it dissolve in sodium hydroxide and produce 2Na2BO3. Also hydrogen will be evolved, 3H2. While in case of aluminum, it dissolves in hot alkali to form hydrogen. It dissolves in hot alkali. Boron can be dissolved in fused alkali, while aluminum can be dissolved in hot alkali to form hydrogen. For example, 2Al plus, when they are reacted with, when they are dissolved with in sodium hydroxide solution equivalence of particle, it will be decomposed into 2NaAlO2 plus 3 hydrogen molecule. It will be evolved. I hope this point will be clear. Also, borates are very stable. Borates is the compound of boron. Here, borates are very stable. While aluminates, that is the compounds of aluminum, aluminates are not stable. Aluminates are less stable. It is not more stable. It is less stable, while borates are more stable. And also, it is one of the compound, that is boron hydroxide, OH3, BOH3, that is very less acidic, weakly acidic. That is weakly acidic, while the AlOH3, that is amphoteric. That is 14 points. AlOH3, the hydroxide of aluminum, hydroxide of boron is weakly acidic, while hydroxide of aluminum is amphoteric. It is amphoteric. I hope you will be know the what is amphoteric substance that can be show that can be act as a acid as well as at the same time it can be act as a base. Here BCl3 is BCl3, that is the chloride of boron. It is a fuming liquid, while here in case aluminum, the chloride of aluminum, it is solid. AlCl3, the chloride of aluminum is a solid, while the aluminum of the chloride of boron is liquid in nature. The aluminum of the chloride of aluminum is a solid in nature. Also, it combines with boron, can combine with metal to form hydride, can combine with metal to form hydrides. Sorry, not hydride, to form borides. The hydride will be the addition of hydrogen. It will form borides. For example, when 3Mg plus 2B react with, when two atom of boron react with 3 atom of magnesium, it will generate into Mg3B2. While in case of aluminum, it combines with, when aluminum combine with metal, it forms Li. When aluminum combine with metal, it forms Li. Also, the boron has maximum covalency as the maximum covalency of boron. Maximum covalency of boron is 4, while the maximum covalency of aluminum is 6. Maximum covalency of boron is 4, while maximum covalency of aluminum is 6. Covalency of aluminum is 6. From the you can give it from the electronic configuration of the boron. Boron has in valence shell, boron has 3 electrons. In valence shell, boron has totally 4 orbitals, while in case of aluminum, in the valence shell, boron has 3s, 3p, 3s2, 3p1, 3d0. It means that boron has many orbitals, more than 4 orbitals, while in case of boron has in valence shell 2s and 2p. So in case of 2p also contain 3 orbitals, while 2s1 orbital. So 1 plus 3 is equal to 4, means total boron can have maximum 4 covalency, while in case of aluminum it can have 1 orbital of s and 3 degenerate orbital of p, while 5 degenerate orbital of d, means 5 plus 3 plus 8 and plus 1. There is in valence shell 9 degenerate orbital present. So that's why the covalency of aluminum is greater than the boron. I hope these points will be cleared. These all are about boron. Sorry, I forgot the camera. These are that is 2s and 2p, that has 2s is 1 orbital and 2p has 3 degenerate orbitals, so that's why total has 4 degenerate orbitals in case of the valence shell of boron. But in case of in aluminum, there has the 1s orbital of 3s and 1 orbital of 3s and 3 degenerate orbital of 3p, while 5 degenerate orbital of 3d. So there is more than 4 degenerate orbital in the valence shell. So that's why aluminum have more covalency as compared to boron. I hope these all points will be cleared. Still, if you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in description box. You can get from there and then contact me. Okay, thank you very much. Very best of luck. These all are about dissimilarity between boron and aluminum. Now Also please subscribe my channel. It make me feel happy that my students are supporting me. Okay, thank you very much. Very best of luck, my dear students. Very best of luck. Okay, thank you.